Good morning, one and all. In this lecture video, we are going to see about the deadlocks. So, what are all the things we are going to see in this deadlock is the agenda is followed here. Like, we are going to see about the system model, and we are going to see about deadlock characterization, methods for handling deadlock, deadlock prevention, deadlock avoidance, deadlock detection, and recovery from deadlock. If deadlock happens, how we are going to recover from the deadlock here. This is one of the main topic in the operating system. Without this topic, we won't be able to understand what is how if n number of processors are requesting for the resources, how the deadlock happens. So that's what we are going to see here. First of all, before going to this, we need to know about the definition of deadlock. So, a process is requesting resources. This is the scenario here. If the resources are not available at that time, the process enters a waiting state. This we already know. A process is running inside the CPU, and one more process is requesting for the resources, but still that process which is inside the CPU is executing its task. The second process has to wait for a certain period of time. So it will be in the waiting state. This is the scenario which we saw before. Now, sometimes if a waiting process is never again able to change state because the resources it has requested or held by other waiting process, so this situation is called deadlock. A process is requesting, but it cannot change the state, that is still it is in the waiting state because the resources it requested or held by some other process. So this situation is called as the deadlock here. So what is the system model for deadlock? System may consist of resources, say for example R1, R2, R3, and it can reach up to Rm. So it may have CPU cycles, memory space, IO devices. Means those resources, namely CPU cycles, memory space, IO devices, etc. And each resource will have n number of instances, and each process utilize a resource as follows. It may request for the resource, it can use the resource, and it can release it. So these are all the things a process can do. And the next is we are going to see about, so that's what how these utilization will be means. First of all, a process has to request for a resource before using it, and once it utilizes and once the task is over, it has to release the resource after using it. And a process may request as many resources as it requires. It not countable, and obviously the number of resources requested may not exceed the total number of resources available. So say for example, if 10 resources are there, only 10 requests can be permitted. 11 resources is not there, and request is in demand, means the count will not be tallied. Okay. A process cannot request 3 printers if the system has only 2. So the available resources itself 2, but the process is requesting for 3 resources, which is not possible. So that's what for a particular process utilization of a resource, we need 3 things. First, a process has to request it, and it has to use the resource, and once it used the resources, it has to be release the resource for the other waiting process. And if resources are available as 2, the process cannot demand 3 resources. So that's what it should not be exceed. So this is the general definition of what deadlock and how deadlock occurs. and what is actually the system model for Deadlock here, and how the process can utilize the resources. So in the next coming slide, we will be seeing about the Deadlock characterization. Thank you.